Security 101 and a little bit more. Let's begin. So every wireless network we've put up in this Nugget series so far has been open authentication with no requirements whatsoever for a user to have a pre-shared key or to prove who they are or anything else. Well, that, my friend, is about to change. And if we want to change those parameters, we simply can do it at the controller by specifying, hey, this wireless local area network, we want to go ahead and start doing some type of authentication. And to do that, we're going to do it on a wireless network by wireless network basis as we set up the security. Now, as we take a look at the radios that controller 1 has within its reach, it says we have 3 radios. 2 of them are up, 1 is down. I shut off AP2 because I wanted to control exactly which access point I was going to be joining. And the other access point, which is access point 3, I put him in sniffer modes so I can collect that data on the access point. So if we wanted to see the frequencies that these were operating at, we could just go to the detail on the 802.11a, click on detail, and this says, okay, AP1 is on channel 64, AP2 would be on channel 161 if it was sending any radio frequency, and AP3, which is currently set up in sniffer mode, is also paying attention and listening on channel 64. And that's how we can collect all the data that we're looking at in the packet captures. So let's add some security. To do that, let's go to wireless local area networks. And we want to add it to wireless LAN 30. So we'll just click on the details of that wireless local area network. And at the moment, it's saying, hey, there's no security policy in place whatsoever. We can fix that by going to the security tab right there and saying, you know what, we want to go ahead and we want to do something more than just nothing, just open authentication. So as a basic example of setting up security, let's use as an example only, let's use WEP. Regarding the key size, we can pick 40 or 104. Now with security, bigger is always better as far as security goes. However, the more bits we have in any type of an algorithm, the more work it's going to take to calculate. So for our example, I'm going to go ahead and just say 40 bits because we're not going to leave just WEP on very long. I'm going to go ahead and say key number 1, I want the encryption key to be bang GOOD, which means not good. So if you do it in ASCII format, it's 5 ASCII characters that we're putting in here. If you say, I want to do it in hex, it would be asking you for 10 hexadecimal characters. So I'm going to say it's 5 ASCII characters. Those are 8 bits each, and 5 times 8 is 40. So this WEP is going to be used to encrypt the data packets as they go from the stations to the access point and vice versa. If we also want to require that key for authentication, we simply check that box right there. Which means once we click apply, anybody who wants to successfully authenticate to this wireless network is going to be required to have that pre-shared key. If you are going to use pre-shared keys, using very long pre-shared keys and very complex pre-shared keys are better than simple and short pre-shared keys. So let's go ahead and apply that. And it's saying there might be a slight disruption in service, especially for people who don't have that pre-shared key. And it's done. Now we have WEP. If we go back to security, so if we wanted to add several different keys, we could. For example, we have key 2 and key 3 and key 4. And by having multiple keys and those same multiple keys at the clients, there's more keys to choose from and theoretically a little bit more secure. However, because it is WEP, the whole thing's not very secure. So we'll just stay with 1 key. And now when I connect from an iPhone or any other client that's a Wi-Fi client, when I connect to that wireless local area network, it's going to say, oh, I need a key to go ahead and authenticate. Now, when we add in the authentication requirement, in this case with WEP, we still have the initial probe and probe response. But this time, when the authentication request comes in from the Apple client, the access point sends this back. And what it's sending back is not a message saying, hey, you're in, it's great, come on in, the water's fine. It's sending back a challenge text to the Apple client. The Apple device says, oh, okay, I got a challenge text. I know exactly what I'm supposed to do. I'm supposed to take that challenge text, take the key that I have, and I'm going to encrypt that, and I'm going to send the results of that encryption back to you. And that's what this packet is right here, packet number 3. This is the encrypted response from the client back to the access point, and then you know what happens? The access point has to grade its work. So the access point looks at this return value and says, is that correct? Yes or no? I mean, the only way it could be correct is if the client has the right pre-shared key. And if it is correct, the response goes back to that Apple device saying, congratulations, good job, nice work. You figured it out. And then the client, being so happy that he passed the authentication piece, says, you know what? I'd like to go ahead and associate with you. Here are my capabilities. And then we have a response that comes back from the access point that says, sure enough, no problem, and we're in. So now this client has successfully authenticated and associated with this access point. So back at the controller, if we want to look at the details, we have one client that's connected. We could go over to the clients option here, and sure enough, there's our MAC address. And it shows here, under authentication, we have a big yes there. And if we want to look at the details of that device, we can click on the MAC address. And what I'm going to do is I'm going to copy that MAC address. Let's say, for example, that we only wanted people to associate with our access point if they were on an access list that permitted their layer 2 address, their MAC address. We can do that. By default, there's no restrictions based on your MAC address. However, if we wanted to set that up, we certainly could. The way we can add on the requirement for the customer's MAC address to be on a list is by going back to our wireless local area networks, going back to our wireless local area network 30 in this case, and under security, we're just simply going to click on this little checkbox that says MAC filtering. So I'm going to click on apply. My little Apple client isn't going to be too happy. But to add MAC addresses in the list, we go up to security, and under AAA, we go to MAC filtering right here. So there's our breadcrumbs. So we're under security, MAC filtering. And if we wanted to add a MAC address, we can simply click on new, upper right hand corner, and put in that MAC address. And you can apply that to any wireless local area network or just to a specific profile. So I'm going to say, let's apply it to every single wireless local area network that we have. You can give it a description. We'll call it iPhone. The IP address is going to be dynamically assigned, so I'm not going to filter based on that. And if we want to, we can associate with a specific interface on the controller. So let me apply this, and that should allow my client to go ahead and reconnect. So I just tried that. If we go back to monitor and clients, I am back in. So it did bounce me as I had that restriction. I was on the list, and now I'm back in. Now the trick is, what if you have 5 or 6 wireless LAN controllers? Do you want to add MAC addresses to every single one of those controllers? The answer is probably not. So what we could also do is we could go back to security and say, you know what? I don't want to just go ahead and use my local MAC address filtering. I want to go ahead and use a central server. Cisco ACS is an example of a AAA server. That doesn't mean the Automobile Association of America. AAA stands for Authentication, Authorization, and Accounting. So what we could do is we could have a centralized management server with usernames and passwords and MAC addresses. And instead of creating these lists of MAC addresses on every controller, we can simply create those lists on a central server, like a Cisco Access Control Server or ICE, Identity Services Engine, and then tell this controller to go check. So if we do specify that we want to check a Cisco ACS server, a couple things really ought to happen. Number one, we should specify where that AAA server is, which is in a separate video, not this one. But we want to definitely define that AAA server. We'd also want to define how those MAC addresses are set up. Are there colons or hyphens or single hyphen or no delimiter for the MAC addresses, depending on how we set them up on that centralized server. So regarding security, we're now checking MAC addresses as well before we let a host associate with our access point. And in the case where there's Cisco ACS or a AAA server and you have local MAC filters, it will check both of those, trying to look for a match before it says no to the client who's not on any of the lists. So in our case, let's go back to the wireless local area networks, go back to wireless LAN 30, and I'm going to say under security, I do not want to do MAC filtering. Otherwise, I know I'd be bringing up additional clients, it'd be failing, and I think, what's failing? Oh, MAC address authentication. I also want to point out that MAC address filtering is not a foolproof method. I mean, what would prevent an attacker from spoofing a valid MAC address and then getting some of those frames into the network? The answer is it wouldn't take too much. So although MAC address filtering can be handy and it might be an additional layer of security, it certainly should not be your only measure of security. In our example, we used a simple WEP key for both authentication before we allowed a device to get onto our wireless network, and that same WEP key would also be used for encrypting data as it's being sent over that wireless network. I hope this has been informative for you, and I'd like to thank you for viewing.